Question 2 here, so complex numbers question. So we're given Z1 and Z2, and we're told Z3 is Z1 minus Z2. Okay, in part A, we need to plot Z1, Z2, and Z3 on the argand diagram. So before doing that, let's get Z3. So Z3 is equal to Z1 minus Z2. So Z1 is minus 2 plus 3i. Z2 then, so minus for Z2. So I'll put it in brackets. That'll be minus 3 minus 2i. So be careful with your brackets now. So we have a minus outside. So multiply that in. So that would be minus by minus would be plus 3. Then minus by minus would be plus 2i. Then we still have our minus 2 plus 3i. So then put the real parts together. So minus 2 plus 3, that would be 1. And then 3i plus 2i, that will be plus 5i. And this is Z3. Okay, so plotting these now. So Z1 minus 2 plus 3i. So going across to minus 2 on the real, up then to 3 on the imaginary. So here we are, and that is Z1. Z2 then minus 3 minus 2i. So over to minus 3 on the real, down to minus 2 in the imaginary. So down here for Z2, and then for Z3 then we just found that, and that is 1 plus 5i. So over to 1 on the real, then up to 5 on the imaginary. So there is our Z3. Okay, for part B then, we need to investigate if the modulus of Z3 is equal to the modulus of Z1 plus the modulus of Z2. Okay, so the modulus of Z3, so remember to do that, you're just squaring your terms. So you'll have 1 squared plus 5 squared. And we'll see, is that now equal to square root of Z1? So that would be minus 2 all squared plus 3 squared for Z1. Plus then the modulus of Z2. So the square root of minus 3 squared plus minus 2 all squared. Okay, so working these out, so this will be square root of 26 is equal to square root of 13 plus then square root of 13. And so square root of 26 equal to 2 root 13. And no, these are not the same. Okay, so if you worked it out in your calculator, this would be like 7.2 square root of 26 would be 5.09. So we can see that these are not the same. So no. Part C now, we need to find Z4. And Z4 is equal to Z1 divided by Z2. Okay, so we have Z1 from earlier. So that is minus 2 plus 3i. And Z2 is equal to minus 3 minus 2i. Okay, so we need to divide these. Now, if you're dividing complex numbers, you always multiply the top and the bottom, so the numerator and the denominator, by the conjugate of the denominator, so the conjugate of the bottom term. So for the conjugate, remember, we just change the sign of the imaginary part. So it'll become minus 3 plus 2i. Minus 3 plus 2i. Okay, so let's multiply these. So at the top we have minus 2 plus 3i times minus 3 plus 2i, all over now minus 3 minus 2i, minus 3 plus 2i. So expanding the top first, so we'll end up with 6 minus 4i minus 9i, and then plus 6i squared, all over now 9 minus 6i plus 6i minus 4i squared. So remember then that I squared is equal to minus 1. So then on the top we're going to have 6 minus 13i minus 6. At the bottom then we can see that the minus 6i and plus 6i will cancel. And then we'll have 9 plus 4. top, then the 6 and the minus 6 will cancel. So we have minus 13i all over 13. So this now is just going to equal 0 minus I, because it's 13 and 13 and minus 13 will cancel. So there's our final answer, 0 minus I.